Welcome to a very quick tutorial all about the horizontal and vertical components of an inclined force, or what I like to describe as unseen forces. Okay, this is really geared around students in Unit 1 of the 2019 engineering syllabus, but it's a good reminder for students in all units as well, particularly Unit 3. Okay, so in this example, here's a picture of my dog. Now let's pretend my dog Bruno is a lazy dog and he's a bit of a lump, okay? Now, what I'm going to do with Bruno is I'm going to attach a lead to him at his collar, all right? Now, the point that I attach the lead, onto his collar is what we're going to call the point of application, okay? And I am trying to encourage Bruno to get up and go for a walk, so I am pulling the lead tight. Now, that lead is said then to be under tension, okay? Now, we can see that tension because the lead, which would normally be floppy and a fabric lead or a chain or something like that, is then going to become straight and tight, okay? So we can see that tension and we can feel the tension in our lead. Now, because I'm standing above Bruno, that lead is then being pulled up, okay? And because I'm standing away from Bruno, it's being pulled to the side as well, okay? Now, let's pretend that Bruno doesn't want to go for a walk and he is just going to lie there pretty stubbornly, okay? So there we've got that tension in the lead. Now, what we can see in that lead, as I said, is the tension, and we can feel, all right, but we can't see those other forces that I just mentioned. So we can feel that there is a force pulling up, and we can feel that there is a force pulling to the side, but we can't see them, okay? So there is actually that horizontal pull going across there and the vertical pull going across there. Now, if I use some really simple numbers for a sec, don't overthink this too much. I'm going to sort of say that there's 120 newtons of force pulling up and to the right at 35 degrees. Now, the reason I'm saying 120 is because he weighs roughly 12 kilograms. That's probably being a little bit unfair to him. That doesn't necessarily mean that there's 120 newtons, but that's what we're going with, okay? So if we've got 120 newtons pulling up and to the right at 35 degrees, we can use that simple force sine of theta, okay, formula to work out what the vertical force is, okay? So then it's just as simple as substituting in. We then look at force vertical equals 120 sine of 35, and if we punch that into the calculator, we get 68.83 newtons of force, okay? Now, we could then go and do the exact same thing with force horizontal equals force cos of theta, and we would get that horizontal force, okay? All we're really doing is creating a force triangle, and, you know, you can then start to hopefully tie that back into what we know about Pythagoras' theorem and trigonometry as well.